All right, so in the last video, we talked about market power and we learned how to calculate marginal revenue when firms have a downward sloping demand curve. In this video, we're going to apply the same ideas to a number example so you can see how all of this works in practice. So here we have a problem. We have one firm in the market, monopoly, right? And we have demand equals P equals 120 minus 2Q. And then we've got a marginal cost equation and a fixed cost, no fixed costs, okay? So only marginal costs in this example. Now we're gonna find the marginal revenue curve. We're gonna find the firm's profit maximizing quantity. That will be given by the point where marginal revenue is equal to marginal cost. And then we're going to find the price that the firm will charge in order to maximize its profits by plugging the quantity back into the demand curve to get the price. All right, so let's go step by step through this problem, right? So here's our important thing to remember here. Always marginal revenue is equal to marginal cost in the continuous problem. In a discrete problem, we want to produce as long as marginal revenue is greater than or equal to marginal cost. So first step is to find marginal revenue. Remember, we're just going to take our demand equation and multiply the slope by 2. The slope of the line is the number next to the Q. So in this case, that's -2. We're going to multiply that by 2, so we get P equals 1, so it's not really P, it's marginal revenue equals 120 minus 4Q. It's not so bad. Now we've got our marginal revenue curve. Let's graph both demand, marginal revenue, and also marginal cost. All right, so we've got our demand equation. That's 120 minus 2Q, so this is 60. And then remember our marginal revenue curve, it's also going to start at 120. You can see that in the equation for marginal revenue. And it's going to intersect the demand curve at half. Sorry, it's going to intersect the y-axis. Oh my goodness, it's been a long day. It's going to intersect the x-axis at half of the demand intercept. So I just take 120, same intercept on the y-axis. For the x-axis, I take demand intercept and I divide it by 2. And again, I got that 60 by taking 120 in my demand equation, dividing it by 2. The same way you could get the x-intercept for marginal revenue, take your 120 in your marginal revenue equation divided by 4, and that would also give you 30. All right, so we've got demand and marginal revenue. Now we're going to graph marginal cost. Our marginal cost curve here starts at 15 and then increases. All right. Good, so we've got all of our equations plotted here. Now we want to figure out, what is this firm going to do in order to maximize its profits? Well, remember, you're only making money if your revenue coming in is higher than your cost. So what we want to do is produce as long as our marginal revenue curve is higher than our marginal cost curve. And that stops being true at this point where the two curves intersect. So this point here will give us our monopoly profit maximizing quantity. And we can solve for that point by just setting marginal revenue equal to marginal cost. So that's 120 minus 4Q equals 15 plus Q. We've got 5Q equals 105, so Q is equal to 21. That's our monopoly profit maximizing quantity. You'll recall from a previous lecture that your marginal cost curve is the supply equation in perfect competition. All right, so we'll use that fact here once we finish doing the monopoly problem to compare what the monopoly is doing versus what would happen in a competitive market. All right, but we got one more piece of information we've got to solve for in our monopoly problem, right? We've got to find the profit maximizing price. So we're going to take that quantity and plug it back into our demand equation in order to get the price, because the firm is going to want to charge the highest price possible. Remember, their goal is to make money. They're going to charge the highest price possible where they can still sell 21 units of the product. And of course, demand represents the buyer's reservation price, or the highest price that buyers are willing to pay for that quantity of this product. So I'm going to take our demand curve, 120 minus 2 times Q, plug in that quantity we just found, and we get that the monopoly will charge a price of $78. Now, on your graph, that means that we're coming up from that quantity to the demand curve. That will be our monopoly price. So this point here along the demand curve, this is the monopoly profit maximizing point. Okay, that's where the monopoly will be operating in this market based on demand and based on its costs. That's the point where they'll be earning the highest profits of anywhere along the demand curve. All right, so we figured out what the monopoly is going to do. Now we want to compare that to a competitive market. How is a monopoly market different from a competitive market? And another way of saying that is to ask, what is socially optimal? Because you'll remember from our discussion of competition that competitive markets lead to the socially optimal outcome. That's where supply equals demand, right? And there are lots of different ways that we could think about why competitive markets are socially optimal. But in this case, very simply, we're thinking about maximizing total surplus. Okay, remember that in competition, we produce as long as the price is higher than the marginal cost curve, right? So this is where price is equal to marginal cost. It's also where supply is equal to demand. This is our competitive market equilibrium. It's also the point that we would call socially optimal. In other words, it yields the highest total surplus of any point in this market. So it's pretty easy to find this point, right? We just set price, that's right, our demand curve, equal to marginal cost. And then we can solve for our quantity. And this gives me a quantity of 35. And then if I plug that back in, I'll see that the price is 50. So I can put that on my graph now. We've got 35 and 50. So what is the monopoly going to do? The monopoly is going to decrease the quantity of the product that they sell. They're going to sell less. Why are they going to sell less? So that they can raise their prices, right? The whole goal of the monopoly is to make money. By restricting the quantity that they're supplying in the market, they push the price up and they'll be able to make more profit than firms in a competitive market. So the monopoly will restrict the quantity or reduce the quantity that they supply in order to raise prices, right? Instead of $50 per unit, the monopoly is going to be charging $78 per unit, and that's going to help them increase their profit. And we'll talk about calculating profit in this context in a different problem. So what's happening here, we can label our surplus at the monopoly quantity, right? Consumer surplus would be this triangle here above the price and below the demand curve. That's consumer surplus. Producer surplus is going to be the area below the price and above the supply curve. And then compared to our perfectly competitive equilibrium, we have deadweight loss. This is our deadweight loss triangle, that yellow triangle there. So consumer surplus is going to be decreasing as the firm raises its prices. Producer surplus is going to be increasing, of course, because that's the whole goal. The monopoly is trying to make money. And total surplus will be decreasing. And we can calculate the decrease in total surplus by solving for the yellow triangle here on our graph. All right. Now we've got the width of the triangle already, right? That's going to be 35 minus 21. The height of the triangle, though, we're going to need to calculate one more point here in order to find it. And that's this point here. We need to know this price, right? What line is this point on? It's on our marginal cost curve and it's on our marginal revenue curve. So we could use either of those equations to find this price. And we're simply going to plug in 21 to one of those equations to find this price here. So we need to know, what is this price? And to do that, I'm going to take marginal cost, my marginal cost equation, since I'm adding here instead of subtracting. That's 15 plus Q. And then I'm going to plug in for Q this 21 units. So 15 plus 21, this P prime here is equal to 36. All right, so now that we've found that extra point on our graph, we can calculate the deadweight loss. It'll be 1/2 times the height of the triangle will be 78 minus 36, and then the width of the triangle is 35 minus 21. So deadweight loss is $294. Simply due to the fact that this market is supplied by a monopoly rather than being supplied by a large number of identical firms, right? The monopoly, it's not good for consumers, right? But they're going to try to earn profits by restricting quantity, increasing their prices. That's bad for consumers. It's bad for society as a whole, right? And on net, we're going to lose, right, almost $300 in economic surplus because of that firm's behavior. All right, so on the next page is another number example for you to work through, just like this one. I'd like you to work through that example and then check your answers either by checking the answer key that I posted on Brightspace under lecture materials, or I will also post a video of me working through that problem as well. So make sure that you understand what we're doing here, because this is one of the big types of monopoly problems that we'll go through. After that example, we'll move on to talk about sources of market power and then price discrimination.